model system with autonomous inland and short sea shipping.
Dear ladies and gentlemen, my name is Stefan Krause from the ICE in Chemnitz, and we are delighted to participate in this year's ICMASS conference and to present the latest findings and results from our International Horizon 2020 project, Aegis, where we try to develop an advanced, efficient and green intermodal system using autonomous inland and short sea shipping transportation. Our project consortium comprises research institutes and companies from the port, logistic and cargo handling industry, combining a very massive know-how from the overall branches in trying to accomplish our overall goal. What is the motivation behind the Aegis project? Basically, we are trying to come up with an improved waterborne transportation system because this is one of the main factors for providing sustainable growth in Europe. That means we are trying to shift as much cargo as possible to waterborne transportation, as stated, for instance, in the white paper from the EU government, and also to provide solutions accomplishing the IMO initial strategy to reduce the GHG emissions by nearly 50% up to the mid of this century and even become totally GHG emission free at the end of this century. So what basically is the Aegis approach? The Aegis approach is trying to integrate new innovations from the area of connected and automated transport, including more diverse sizes of ships. That means much more flexible ship systems, automated cargo handling at ports and short sea shuttles, as well as standardized cargo units and new digital technologies in order to design the next generation of the sustainable and highly competitive waterborne transport system in Europe. Therefore, we try to tackle several specific objectives, such as the green transportation, the provision of a robust and transport system, the enabling of higher speed and more flexible timelines and frequencies, providing a better rural connectivities of hinterland areas, as well combined with the last mile automation in terms of providing a better urban connectivity, and last but not least, being able to provide user-centered services. The Aegis project investigates this improved waterborne transport system on 3 different use cases. In use case A, we are focusing on an efficient connection and interaction between short sea shipping and local and urban cargo distribution. In use case B, we are focusing on ro-ro transportation from several Western European ports and the inland navigation, establishing and waterway connections between ports and smaller inland destinations. That will be accomplished using automated inland waterway transportation systems with zero-emission vessels. In use case C, we are trying to come up with systems in order to revitalize regional ports and city center terminals, where basically we are focusing on the key elements such as lower overall costs, higher feeder frequencies, and a much more competitive ro-ro segment. And the basis for that will be provided by a multimodal green and logistics solutions. Let's have a closer look at the use case A. As I mentioned, there we are focusing on the short sea transportation from Western Europe to Western Norway, and also the transportation in the rural areas in Norway. Therefore, we are looking at the short sea transportation from Rotterdam along the western coast of Norway, from Stavanger, Bergen and Ålesund up to Trondheim Fjord. And then we are looking at the transportation in the hinterland transport within the Trondheim Fjord. Therefore, we investigated several micro-scenarios, which basically gives us the input information for the ship development. Here you can see some examples of possible micro-scenarios, such as the transportation from Sandstad to Orkanger, from Orkanger to Steinskjer, or from Frøya to Stansted. Each of these micro-scenarios offer different requirements on the vessel development. So basically what we are trying to accomplish here is using a mother-daughter vessel approach in order to get a much more frequent and efficient waterborne transportation system. Therefore, we are using mother vessels in 2 different sizes. As you can see here, we are having container vessels with a size from 900 to 1000. And we have a slightly smaller mother vessel with a size or capacity of 200 containers, which will travel along the Norwegian west coast, but not the far distances up to the western coast. Those mother vessel concepts basically will be propelled by a hybrid propulsion system using electrical and also methanol and ammonia biofuels. In order to be efficient and independent from land-based cargo handling systems, they all offer onboard cargo handling systems such as triple joint cranes or onboard cranes that will be developed together with our project partner MacGregor. And in order to be much more efficient in terms of overall costs, we are trying to reach an automated level in the terms of the IMO regulation of 1 to 2 and 2 to 3 that offers the remotely controlled crew on and off board. For the transportation in the hinterland, we have come up with several concepts so far. The first concept is a convoy concept. Basically, the idea is to propel a convoy consisting of several barges by a pusher, and this push bar reaches also a highly autonomous level, and it could be operated without crew on board or remotely controlled or fully autonomously. And it will offer a green transportation based on the use of fuel cells and batteries. And in addition to that, we have the unpropelled or slightly self-propelled barges, which offer a number of benefits. They will provide the opportunity to transport different types of cargo goods, such as bulk, containers, or other types of good. It can be used in the ports, in the rural ports especially, as a storage unit as well. And it comes with its own onboard handling system, so enabling also a cargo handling system for customers which don't own such an infrastructure. And the slightly self-propelled propulsion, we are looking into providing a propulsion system that enables the transport of the barge over short distances, such as from the convoy itself to the final destinations. The overall longer destinations, however, from the rural destinations up to the mother vessel, will be provided by the push barge. In addition to that, we also designed a smaller daughter vessel concept that could also be self-propelled and powered by batteries as well as regional high biofuels. It is designed to reach a highly autonomous level. That means we can provide a service without a crew on board, that will be remotely controlled or fully autonomous. That autonomy level will be generated by using sensors such as LiDAR or other systems as radar cameras and GPS. In addition to that, we are trying to develop an automated mooring system. A very big factor to enabling an efficient handling transportation is the onboard cargo handling system that will be here provided by a fully automated lightweight built gantry crane that offers the possibility using a telescopic spreader to provide transportation and cargo handling of different sizes of containers, reaching from 20 to 40, 50 feet containers, which is officially beneficial for the shipping industry. In the use case B, we are looking at the inland shipping transportation at the interface in Belgium and the Netherlands. Basically, we try to come up with automated shuttles that enable a better ro-ro transportation of trailers that are now often stuck in traffic, and such provide a much more efficient, less CO2 emission type of transportation, and thus reduce the congestions on road and in the port areas drastically. Therefore, we are looking in 2 different directions in the development of the ro-ro barges. For the bigger types of the ro-ro barge, as you can see on the left pictures, we are trying to stack the trailers in the rectangular direction, what gives us the advantage that we don't need big ramps and infrastructure in the port, and also will be able to provide customer service for customers that don't have such much cargo, so we have a very good frequency adaptability to the requirements of the customers at the end. And also we are looking into smaller ship sizes, therefore we have the opportunity to get the trailers over those small barge concept as far to the final destinations as possible. With that, I would like to sum up the results we developed so far. So far, we will be able to establish 3 use cases and develop specific user scenarios. We were able to develop the first draft designs of our advanced green and autonomous vessels to the specific use case conditions. That means we were able to develop mother and daughter vessels, as well as autonomous shuttles and barges so far, and also ro-ro vessels for different inland waterway transportations. In addition to that, we developed together with a project partner DTU KPIs, which comprises economic, environmental and social KPIs in order to evaluate the draft vessel concept. The next steps within the project is the finalization of the developed logistics simulation tool in order to evaluate the vessel designs and to see what adaptations are necessary for different types of micro scenarios I showed you earlier, and to show what levels of improvement we will be able to generate. And in the later stage of the project, we will also build a demonstrator of autonomous cargo handling systems at the stage of MacGregor, where we also try to investigate that. With that, I would like to come to the end of my presentation. I thank you very much for your attention, and I'm open for questions. Thank you very much.
Okay. Thank you very much for the presentation. We have time, I think, for 1 or 2 short questions. Could be tempted to ask one question myself. You talk about mother vessels and daughter vessels. Could you say anything about how they are supposed to interact? Yes, as there's supposed to be any, I assume there's supposed to be some interaction between them.
Yeah, thank you very much for your question. Warm greetings from Germany. The interaction could be directly by a direct interaction in terms of handling over the cargo from the bigger mother vessels to the daughter vessels on sea operation. But basically, in this use case where we investigated the Trondheim Fjord area, we are looking at a switch so that the mother vessel shifts the cargo on a landscaped cargo handling base in Sandstad in Hitra. And then the daughter vessels will collect the cargo goods from there and spread them out in the hinterland areas inside the Trondheim Fjords area or along the Norwegian west coast. But obviously, the interaction between mother and daughter vessels in the cargo handling could be a possibility in this scenario.
Okay, think. Let him can have a microphone. Quick, very quick one.
Quick one. The automatic mooring system. Can you explain a little bit more about that?
Yeah, the automatic mooring system. We are still in the conceptual phase of the studies because there are different scenarios we are currently looking on that has to work in the bigger port areas, but also we are trying to come up with a solution that is able to operate in the more rural areas where we don't have these the infrastructure necessary for that. So there are different concepts. We are looking at it right now, and it's not developed to the final stage yet.
Okay, thank you once again for the presentation.